Welcome back to the Matrix. We're back again with the technical prophet, the constructor who's always on the bleeding edge of the Matrix and everything else. That's Gabe Arnold from the, I'm going to get it this time, Greg, Pacific Northwest National Laboratory.
Pretty good. I would have said laboratory, but we'll give it to you.
That work? Yeah? Okay. Hey, that was a fun chat with Gabe.
Yeah, he's one of the guys that you'll find out has been at the forefront of a lot of the industry and one of the leaders. So it's great talk.
Yeah, it was funny because we kind of discovered it by accident that but he is a technical prophet. So this is a man to watch in the game. Another company to watch in the game, Greg, is TCP.
Not always watch them, be part of them. Great company.
Well, the craziest people in lighting. Come on.
That's right. They've got a new smart stuff, they call it. It says, imagine if you could curate your lighting throughout the day without ever having to flip a switch. So what we talk about often on this show is, I want it just to be right without having to actually manually do it. They have that capability with their new smart stuff. It can go in all of their integrated in their fixtures, and their light bulbs even, and it can allow you to schedule lighting automatic to the hands-off elegance that you want. How nice does that sound? Elegant lighting, hands off. They take care of it. The smart stuff can do that for you.
Smart stuff, yeah. It's it's time for a new story. I'll tell you, there's something to that color tuning on its own, not having to choose it, which excites me a lot.
Yeah, just do it for me so that I want it the way it needs to be. You pick it.
Yeah.
Lay it down. Let's go.
Yeah, you just let me put in my coordinates and then you just run with it for a while. Like, I feel like that's a move you can make with a customer. I don't know, maybe.
Oh, for sure.
I'm a sales guy, but it's like, I think you need both. You need to be able to control it, and then you need to back to override again or something. You know what I mean?
Yeah, the capability to say, I don't like this, and then you can change it. But at the beginning, I want somebody to tell me how I can have a better day. Make it that way. Make it so.
Yeah, just let it ride. So go to tcpi.com, baby. That's tcpi.com. And, of course, the National Association of Innovative Lighting Distributors. That's naild.org. And for right now, folks, it's coming in hot. Gabe Arnold from the Pacific Northwest National Laboratory, PNNL. Welcome to the Get a Grip on Lighting podcast, Gabe.
Hi, Mike.
Say hello to Greg Eric.
Hey, Greg.
Hey, Gabe. Thanks for coming on.
So you're the second person we've had on from Pacific Northwest National Laboratory.
Might be third or fourth.
Might be third? Oh, okay.
Yeah, or the Queen of Flicker.
There you. I forgot. Yeah, I forgot about her. So yeah, we like to dip into that pool and pull out and see what's going on. Tell us a little bit about your work there, Gabe.
Well, I'm actually fairly new to PNNL. I've been here almost a year. I started this past January, and most of my work has focused so far on this study. I think was why you invited me to look at DC lighting specifically and DC building microgrids. I've also been doing some work looking at connected lighting technologies, IoT, and so forth.
And you had worked at the DLC in the past as well?
Yeah, that's right. Before PNNL, I was technical director at DLC for a number of years.
What did that involve, being the technical director?
Well, I think I oversaw all of our engineers and scientists and really setting our technical direction and establishing our specs.
That sounds like a bit of a ruckus ride over the last 10 years.
It was a good ride. I would call it an impactful ride.
How long were you at the DLC for? When did you start there?
When did I start there? 2014 was when I became an official employee of the DLC, but I was involved in DLC really since they began the qualified products list.
Yeah, 2014 and that you're those are early days, right? A lot has changed in lighting since 2014. Like, it's almost like the industry. I don't know if there's an industry that's changed more than this since 2014, actually. I mean, you go from the energy story to now a health effects story to now a other controls and all that. What was it like to see that from to see the products go from, say, this, on the list, and then adding all the different things that you needed to add on to that as you went along?
I think it was really exciting. I think this is one of the most exciting industries you could possibly be in, and it's for all that innovation that occurred in such a short period of time. And, I was involved really at the very outset of the DLC. I don't want to take credit for starting it, but I was the person that showed up to a meeting with a number of utilities and said, "Hey, let's collaborate on a list." And that was a time where we were just starting to see uh, LED technologies that were real. I think up before that point, this was all hype, and I still remember the day that we had a salesperson come in from a company called uh, Linear Lighting Fixers (LLF), and they showed us what was called the LR6 downlight. Cree eventually purchased that company, but I still remember that day they brought that in and showed it to us, and I was like, "Wow, this is actually a real technology," and that's really when the ride started. I think it's funny. Before that, we used to get excited about things like high performance T8 ballast and
Yeah,
high
baby.
lumen,
Yeah.
and high lumen T8 lamps. And
We got the 25-watt TA. We came out with it first. I remember a vendor told me that we were the first ones to come out with the F25 25-watt F32 T8 or something. I'm like, woo. But now, I mean, the transformation has been absolutely unbelievable, actually, if you were to try to predict it.
Yeah. So it was quite a ride at DLC. I think it was it was there were it was hard probably all along the way, and I might say it got a little bit harder in later years, probably because of some of the challenges that the industry was facing out there. And as you were looking to kind of continue to try and move things along to higher quality and performance, it became a little bit harder to kind of get the support of everybody around those things.
Why did you guys, or what made you come up with the idea of the list? You saw an LED and then you saw another one and then you started saying, all right, what's going on here? We gotta come up with this list, or where did it come from?
Well, we were all kind of duplicating efforts. I think all the utilities were being barraged by all these manufacturers showing us all kinds of products. Most of them were really bad. And it was around the time that DOE was running their caliper programs, and they were verifying through those reports that a lot of these products are actually pretty darn bad. They're producing pretty poor quality of light. They're probably not going to last very long. And so what was happening is each of the individual utilities were attempting to do some validation of the products to make sure that what they provided rebates or incentives for and made it into the customer's hands were actually going to be good products. And so you had a qualified products list that was forming from Efficiency Vermont, where I worked, with National Grid in Massachusetts, and Eversource in Massachusetts, and Pacific Gas and Electric out in California. And it was kind of obvious the opportunity there. Why are we kind of duplicating this effort here? Why don't we collaborate on this? And kind of the rest is history. It blew up from there.
So you are good at knocking heads together then.
Collaborating, yeah. Yeah.
So
I wouldn't call it knocking heads. Yeah.
Sometimes you need someone that can knock heads together. What are your thoughts? Like, I was in this thing from 2000 and all the T8s and CFLs and then PAR 38 CFLs and then all the stuff that happened and all manner of rebate programs, direct rebates, over the counter, engineered, custom, prescriptive, all different kinds. And I look back and I say to myself, there's a lot of things I would have done differently if I had it all to do over again. Like if the industry had it all to do over again, I would have done a few things differently. What would you have done differently?
That's a good question. I don't know. I would say what I would have liked to have done differently. I don't know if it actually would have been feasible to do. And that would have been to try and incorporate more quality at the outset into these qualified products lists with LEDs. I think, there's been a lot of emphasis on lumens per watt. and the efficacy. And I think really from the beginning, the DLC and the utilities understood the importance of the other aspects of quality, beyond efficiency in the products that were being promoted. And so, we had requirements for CRI and making sure you have good color rendering, and we had some requirements for lumen maintenance to try to ensure that the products were going to last or have some level of reliability. I think there's all kinds of other aspects of lighting that of lighting quality that go into reliability, such as like the reliability of the driver of the whole LED luminaire, the glare performance, and these are really important issues. And the metrics didn't exist to address them when we first launched the DLC. So, one of the things that happened over time is as we continued to drive for this higher efficacy, um, some of the ways that started to be achieved by some manufacturers that maybe had less of an emphasis on quality would be like eliminating any glare control or optical control, and you'd end up with these sort of glare bombs with exposed LEDs. And I think if there was a way to address that at the very outset, that would have been a nice thing to do early on. This is something that DLC has been addressing now over the past a couple of years, and it's been difficult to kind of come in and make sort of a course correction around those issues after the industry's kind of come so far along.
I think part of the problem was you had competing. A lot of people thought that the DLC worked for the lighting industry, but they don't. The DLC works for the utilities. And so they're coming at it from a different angle in terms of what their end goal was to make sure that, what we were rebating here actually works. I think that's different. That's a different priority than the other aspects of lighting, some of which you brought up, flicker, glare. There's a bunch of different areas where it seemed like the DLC learned on the job. And they kind of rose in prominence within the lighting industry. And I think it kind of felt to a lot of people that they weren't lighting people. They were utility people. Is that a fair analysis from the outside?
I can see how you'd have that observation from the outside, but having been there, I can say that these issues were well understood by the staff at DLC, and certainly a lot of the staff there, did come from the utility space. But there's also a lot of staff that came from the industry side of things, and it was really more of an issue of we lacked kind of the metrics and the science to begin to apply some of these aspects earlier on in the specs.
One more question about utilities, and then we'll move on to what you're doing now at PNNL. You said that you were employed by Vermont, the state of Vermont electrical utility?
Yeah, there's an organization here called Efficiency Vermont that runs all the efficiency programs for all the utilities in the state. So it's one statewide org.
One statewide organization. Let me ask you, why would utilities pay people to use less of their product? Like, how is it that work? How does that work? Like, if I don't want to pay people to buy less light bulbs from me, and I think I've had this question answered for me before, but I've never really fully understood why the utilities pay people to use less of their products, and how do they make up the revenue? Do you know?
Yeah, I do. I mean, it started really as a directive from the regulators of the utilities, who are really charged with a utility is a monopoly, right? So there needs to be some regulation, and they're really charged with ensuring that the utilities are delivering the lowest cost electricity to the ratepayers in the state. And what happens is, as we start to reach capacity of our transmission and distribution power lines and our power plants, and we need to upgrade them, upgrade our power lines or build new power plants, that becomes really, really expensive to do. And it's just getting more and more expensive to do these things. And it turns out that if you do energy efficiency instead, and therefore avoid the need to do these upgrades or build new power plants, it's a lot less expensive. And so that's really the driver for it that was driven by the regulators. I think over time, the utilities have all gotten on board with this from the perspective of just making sure they're providing, the best service to their customers and the best costs. And, they're starting to face some competition as well out there from things like, customers going off grid and so forth. And so, yeah, I think today the utilities are all fully subscribed to this model. But yeah, does that answer your question?
Yeah, it still makes me confused though, because Ontario's got tons of rebates and way too much energy. Like it never made sense to me. So like Ontario produces so much clean nuclear energy and we have to pay Michigan to take it. And like it never
pay Michigan to take it, or
that
Michigan
we have
pays
to
you a lot for it?
No, we have to pay them to take it. Because we have too much of it, we don't use it all. I also heard the CEO of Ontario Power Generation stand up and say that if everybody in Ontario got an electric car, the cost of electricity in Ontario would go down because we wouldn't have to pay Michigan and Upper New York State to take our power.
Interesting. I don't know the situation.
I know, but like it's then this is what they tell me though. So we don't have to build more power plants. And I'm like, hang on, that guy over there just said that we got way too much energy, and the problem is that because you can't turn these nuclear power plants off, there's no adjusting them. They're either on or off. And he's like, we got all this clean energy, but we can't use it all because we don't have enough people using electricity in Ontario, so we have to pay to get rid of it. And then the other guy over here says, yeah, the whole idea of rebates is so we don't have to build any more power plants. It's like, hang on a second here. What's actually happening? So I was always confused by that. But Greg?
Yeah, I mean, in addition, I think they charge for it too. I mean, on your bill, they have a resource adjustment fee, and then that's where the rebates come from too, right?
Yes, correct.
Yeah, yeah. So I think that's part of it too. But yeah, I don't know that there's ever a clean answer, Mike. We've asked that before, and I kind of have the same questions too. And then in turn, our end users and our customers ask us, and we have to relay it. So we're like, I'll just take the rebate.
Don't get too complicated, guys. Just take the money, would you, and upgrade your lights.
So no, what we wanted to talk, you did a white paper on DC lighting and their DC grid. Before we get in, can you explain briefly? I know this is intro level, but just there's AC power and there's DC power going into a building. Tell us how that works and what break it down. It's in your white paper here, but if you could sum it up.
Yeah, sure. I'd almost refer to these as kind of like two different formats of electricity. We've got alternating current and direct current, AC, DC. They're also alternating current, like coming out of your outlet in your home is 120 volts, and it's alternating from positive 120 down to negative 120 to positive 120, and it just keeps alternating like that. Whereas direct current is going to maintain if it's 120, positive 120 volts. And they're just two different ways of providing electricity to a load. And there's a whole story behind this called the War of Currents. If you go way back, it was Thomas Edison versus Nikola Tesla. Thomas Edison had the DC, Nikola Tesla had the AC. They were competing to see what would light our homes and buildings for the next 120 years, and Tesla won that one with AC. And so that's what's distributed through the electric grid and through our buildings today. And some would say that there's a resurgence of DC as maybe a better option to distribute power in buildings and through the grid.
Okay, and so why, and your paper here says that DC lighting is the way of the future, or is going to be, or where are we at with that?
I think that's a little bit remains to be seen, but I think there's a lot of benefits to DC lighting. I guess I should probably clarify that all lighting is inherently DC. Really, any sort of electronics, solid state source is going to require DC electricity to operate. And so what we do is we take the AC power from the grid that's in our building, and we're converting it to DC at the LED lights. So within the driver, the LED driver, the first part of that driver is a circuit that converts the AC power in to DC that the LED actually uses.
And I read in your white paper here that that's the majority of the issue with LED life is a driver, and you did a test, DOE study. Can you explain that, the results?
Yeah, there's a DOE study, it's probably a couple years old now, that did some accelerated stress testing of LED drivers. And what they found, I don't have the numbers right in front of me, but what they found is that all the failures, or the majority of the failures, occurred on the first stage of the LED driver, which is the circuitry that takes the AC power and converts it to DC, and also conditions that power to make sure that you've got a good power factor and total harmonic distortion. And so the idea is that if you can eliminate that that conversion circuit and an LED driver, for example, well, there's a few things that you can get. Number one, you can potentially have less expensive drivers because you don't need that circuit, but you can also eliminate kind of the weak point in your LED, which is often the driver and that particular circuit.
Just to
Gabe's,
clarify,
hang on,
it did say
hang on.
the numbers. I want the numbers.
Hang on one second. I just want to say something. Gabe's like a technical prophet. He's on these, he's always on the forefronts of these movements. You know, it's like lighting, and now you're like on the forefront of this whole thing. I got a ton of questions, but I'm going to go back over to Greg because he's getting specific.
Yeah, just clarifying the numbers for the listeners. It was a LED driver. So you did a stress testing in 6,000 hours, and 64% of the drivers failed. And all of them was because of that stage one driver circuitry from AC to DC. So 64%. It's a huge number.
Yeah, right. Not surprising, right? We've maybe heard, maybe you've read about this or not, but that circuitry has an electrolytic capacitor in them, and those are the things that often fail within the drivers.
Electrolytic capacitor. Okay, so
yes.
Now, Ontario's covered with these giant steel monsters. They have lots of lines on hanging from them in there. Like Ontario has miles of this stuff out there. Where are we going to, like what you're saying is we're going to stop converting to DC at the socket, and we're going to start converting to DC where? Or are you going to get rid of all the AC grid? Like, is it going to come in from the grid at DC, or is it at some point converted?
I don't think so. This is not something that's going to happen very quickly at all. If it does happen, I think there's absolutely going to be certain niche applications where DC takes off. I don't think changing the grid to DC is anything that's going to happen anytime soon. I think where the real promise or potential of this technology, maybe where it provides the most benefits, is where you've got PV, solar panels on your building, and energy storage batteries, which we'll be seeing more and more of. And the reason for that is because your PV panels, they're generating DC electricity. Your energy storage batteries are storing DC electricity. And if we wanted to power our lights in our building, the way we do it today is we take the DC from our PV panel and our battery, convert it to AC to run it through our building, then back to DC at the load. Every time we do that, we're losing energy. We're introducing failure points. We're putting in equipment we don't need. So let's directly connect these things.
You know what's hilarious is that Ontario did this whole solar microgrid thing where you could set up solar panels and get paid way more for the energy than the cost of electricity. Like 10 years ago, they did this. It was a debacle, but it ended up being a debacle. Debacle. I don't know how you pronounce
debacle?
That. Debacle. Yeah. Debacle. I don't know, whatever. It ended up being a big debacle. And you know what was funny? I was talking to this guy who did a lot of it, and he goes, you know what? If it wasn't for the damn inverters, those solar panels would be great. The inverter is what changes it from DC to AC, right? And he's like, shit, yes, man, we're changing inverters all the time. They're constantly blowing out. So this whole idea of converting from AC to DC or flipping from Edison to Tesla back and forth just seems like a whole bad idea.
It makes no technical sense. The only reason we're doing it is because that's the way we've done it for 100 years. So, yeah. So hopefully we can make some headway on that. And I think, lighting's a great application to start with. It's not the only DC load in the building, but I think it's a good application to start with.
It's interesting.
So you see,
You also plug. Sorry, Greg. I get just so excited about this. You're also like always plugging in all these adapters, and my kids fighting about adapters all the time. That's to convert from AC to DC, Greg. Stop the fights.
Yeah. Direct connect. So are you seeing a lot of results with buildings actually going to DC lighting? I know there's product out there, and I know there are applications, but I don't know of any locally that I've seen. Mike, have you seen anything with DC lighting?
Yeah, so I met a guy who was like a off grid kind of dude, and he had solar panels and a windmill, and like he had battery. He was running batteries. He had these lead acid batteries, a shed full of lead acid batteries, I think, or something. They looked a lot like car batteries to me, and he ran his whole house off the grid. And then his backup was like a propane generator. And so he was converting all of his plugs to DC and all. He's like, "Can you get me any DC only lights?" This was like 5 years ago, actually. So he was ahead of the game, and he wanted to convert his whole house to DC because, yeah. So I did. That's the only time, though. That's the only time I've ever seen it. I told him I didn't know where to get anything. So I said, no, I'm like, I don't know where to get that stuff. But but now is it available, Gabe? Is it widely available?
It's becoming more available. I would say it's still a niche application, and still people that are on the leading edge there that are trying it out. I think there's one particular type of DC lighting that's gaining out there, which is power over Ethernet. And we don't have any numbers on exactly how much of that is being installed, but indications are that it is gaining some steam out there, and there have been quite a few installations. We've got some anecdotal numbers just talking to the manufacturers that are playing in that space. And I think one sign of it is just looking at, I think in our paper we identified that there's 17 lighting manufacturers that are now offering their luminaires with PoE as a standard option. And one thing that's telling about that to me is that it's not just startups in that list. And we've got some big players that are in the PoE space offering their luminaires that way. It's Cree, Signify, Hubble, H.E. Williams, Amerlux, plus a lot of other smaller companies in there. And hopefully those big companies have done their homework and they're seeing the market there and the installations. But I think that's one that's potentially got some potential for greater adoption here. You need to sort of caveat it though. So PoE, while it's taking DC from a PoE network switch and distributing that to all your luminaires, the PoE switch itself still accepts AC, and so there's a little bit of an evolution that needs to happen there to connect PoE to the PV panels and the batteries by making those switches have a DC input.
You know what that sounds like? And just like that sounds like there's going to be a ton of early adopters that get burned. Like I hate to say that. Like a PoE lighting system. If you called Premier Lighting and said, "Hey, Greg, I need to replace this PoE lighting 2x2 in my office. I got it 5 years ago or 3 years ago." I don't think anyone's going to be able to have an answer for that. And so I think it's and I don't mean to be overtly critical. I wish the PoE guys all the best, but I think that there's long-term trouble in replacement parts, maintenance, components, stuff like that in that space right now. How do you feel about that?
Well, I think anytime you're adopting new technologies, there's a risk like that. And there's a reason they call it the bleeding edge and not just the leading edge. And I think there probably is going to be some of that. And, usually what you'd recommend is that you maybe stick with some reputable manufacturers who will stand behind their product over time. But even then, there's probably going to be a risk for what you described. Yep.
So now to do this, let's take a building that's existing. My building right now, I have AC power coming in, AC to everything, then it converts to DC back and forth, whatever. How do I make DC lighting in here? What would I have to do?
It depends a little bit on the type of DC that you're doing. If it's you'd probably, If you're doing a PoE lighting system, then you'd need to basically run new distribution, Cat 5, 6, or 7 cable to all your light fixtures from some sort of central place where you've got your PoE network switch. There are other types of DC out there that are running 48 volts from some central hub out to their light fixtures. And in that case, you might be able to reuse some of the existing wiring. I know there are some systems out there that enable you to do that. I think that really the opportunity here, though, is going to be more focused, at least in the near term, on new construction applications rather than retrofit. Yeah, more cost effective. Anytime you got to replace wiring, that's going to add a lot of cost.
Does DC have a live and a neutral? I don't know. Just like how you know what I'm talking about? You have the white and the black or whatever. Does it have that as well?
Yeah, sure.
Okay. Mm-hmm. So there's a neutral load, and then when people are doing this, what is the advantage? Like, what is the business case? So someone comes to, let's say, Apple wants to build a new facility, and lighting guy walks in. He goes, "You got to go PoE.
Yeah,
you got to go PoE. You got to go PoE here." Like, is there clear advantages to power over Ethernet?
Yeah, let me just clarify. You can have a neutral. You don't always have to have a neutral. You'll have a positive and negative, and you can put a neutral in there as well.
Okay.
So that's not always the case. But the advantages to PoE, number one, the manufacturers are all claiming reduced installation costs, and I think that's probably real, and it has to do with the fact that PoE and really a lot of these DC systems are using class 2 voltage as defined by the National Electrical Code, and that's below 60 volts DC. And when you get down to that level, all of a sudden you don't need to run all of your wiring and conduit. And all of that conduit that we put in buildings with line voltage wiring, that we've got to route through the buildings, we've got to support it, you've got all the fittings and terminations, and you got to pull all the wire through it. That's a lot of cost and material and steel and also time to do all of that. With PoE, with low voltage DC wiring, that can be eliminated in most jurisdictions across the country. So eliminating all that conduit, that's a big cost savings. There are also arguments made that you don't need an electrician. That may not be true probably in most jurisdictions. We've done some follow-up research on that. And, you probably still would have an electrician in most places run the cable. So that's not really where the savings are. It's really the time and material savings of eliminating that conduit. There's a couple of other benefits. One is that you can, when you're in that class 2, you can run your power and your control together. The electrical code doesn't allow you to do that with line voltage.
Sure.
And the third benefit is going to be integration with other building systems, because PoE is using this internet protocol, TCP/IP, which a lot of other systems will use over time, and that's going to enable us to develop smarter buildings. It's kind of this convergence. Sometimes you hear of ITOT, information technology with operational technology. Our buildings, for whatever reasons, have continued to be analog for so long. It's kind of like bringing them into the digital realm.
The energy savings story too. There's a 10 to 18% for going to DC lighting from AC lighting. Just in looking at it, how do you quantify that, or how do you know what the actual wattage is of it? Like, you have an AC light that says it's 100 watts. Is the DC automatically 85, or is it going to say 100, but it's only going to use 85, or how does that all work out from a calculation?
Yeah, that's actually really is more complicated. I'll try to explain it. But that 10 to 18% savings is really only in the microgrid scenario, where you've got your PV and your batteries, and you're eliminating those two conversions between your sources and your loads. If you've there's really arguably there's no energy savings or little energy savings just by using DC over AC. And there's a recent study from California Lighting Technology Center that looked at this, and you can look that up, and they found that there really wasn't any energy savings by centralizing your AC to DC conversion versus doing it all of the loads. So it's not really an energy saving story by itself. DC lighting, it's really a system energy savings opportunity.
You know what it sounds like? You know what's interesting when you talk about it, you're describing it. It's like this. So I still think the lights that I like the most are halogen. I love the way halogens dim, 0 to 100, like you have a dimmer on the wall. And yeah, LEDs can dim, but nothing dims like a halogen and the warming of the halogen and the way it smooth, perfect dimming, right? And so that was like AC goes directly to light bulb. What you're saying is DC goes directly to light bulb, just like AC used to do before we started getting all complicated, right?
Yes. Yeah. No. Exactly. Good analogy. Yep.
Yeah. Huh. So let me just I want to throw something back at you because I actually own an electrical contracting company. And so what's interesting about a lot of people when they talk about this, it's like this whole idea of lowering the installation cost because this is not considered, you don't need to run the cable inside conduit. They kind of sound like they're getting away with shoddy work, because the wires aren't in the pipes just for like fire reasons. It's actually a good way you need to organize wire in a building and protect it. Like whether it's the only reason to protect it is not just shock. It's just super inconvenient if a wire breaks somewhere in the ceiling. Right. Mm-hmm. And so these wires are shielded so that, someone's up on the ceiling up there doing something, hanging something from the T-bar of they jab it, it bounces off the conduit. It doesn't pierce the wire. So there's other reasons that you want wires really heavily shielded in a building. It makes it like safer for the wire, and then you don't have all these hassles of broken cables. So that I don't buy that part of the argument. But what I do buy, Greg Eric, about this PoE, what I do buy is this is how we get into the matrix. This is how because that's all data cable, right? That's all data transmission cable. You're going to have one more conversion point at the end of this, Gabe. And that's going to be when the information turns from whatever goes through cables into LiFi. And then the entire interior space is the internet.
Mm-hmm, mm-hmm.
That's what's going to happen with that.
Mm-hmm. I hope so.
What? Are you crazy? That's so scary, man. That's so scary. You're actually going to be in the matrix. You understand? Like it's good. They're going to be able to transmit information back and forth through the light.
Yeah.
That PoE.
Ones and zeros flowing through the light, basically.
Yeah.
Yeah.
So, Gabe, you think this is something that's going to take off then? DC lighting is a ticket, or is it going to stay a niche?
I think that PoE's got some momentum, is going to gain some adoption. How much remains to be seen. There's studies predicting that's going to go exponential. We see a lot of these types of studies. The other types of DC, I don't know. We'll see what happens there.
You know what, though? You've seen it happen once before, Gabe. If you go back to 2009 and everybody says to you in 2020, there's going to be no Philips, GE, or Sylvania. They're all going to be out of lighting. And, this adoption of LEDs will be out there to this point. You would have said, nah, that's not possible. But it happened.
Mm-hmm. Yeah, I think so. I mean, this transition's harder, but yes. The LED transition was big and it was disruptive, but it was a little bit easier, right? Swapping out just an old light source for an LED source, that was easy to do. This type of change impacts not just the product you're installing, but it's also the practices and so there's a lot of changes that would need to occur there to really disrupt the industry at this level. And I'm not saying it can't happen. I'm just saying it's harder. It's probably going to be a little bit slower, but I'm optimistic that we'll get there eventually because I think there's a lot of benefits.
I think that circadian healthy is going to collide with PoE in a beautiful, gorgeous explosion. That's what I think. Mm-hmm. Yeah. Gabe, thanks for being a guest on the Get a Grip on Lighting podcast.
Thank you for having me. It's good to talk with you.
Smart stuff from TCPI.com. Greggy, smart stuff.
Smart lighting made simple, it says. And that's the issue right now with smart lighting is it's not simple. But TCP's got the ticket to make it that way. Schedule your lighting, hands-off ambiance. Pair with the remote for the most control and flexibility you want. Easy install and setup. It's got it all. It's new. It's hot. Check it out.
Go to tcpi.com. The craziest people in lighting always cooking up something. And this one sounds like a bit of a game changer, Greg Eric.
That's right. Coming in hot with the smart lighting. Something to be aware of and be ready for. And do.
Whoo! National Association of Innovative Lighting Distributors, NAILD.org. That's nil.org. That's right. Get associated. You know, pretty soon we're not even going to let you listen to the podcast. That's what we're really going to do to you guys. So don't join. We're going to shut you down. No, of course, we love you guys, all of you, NAIL members or not. Thanks for listening. Bye for now.
Written on the rectory wall, there's a sign there for all. You are lost, Lord is there to find you.